Okay, so we're going to look at transforming specifically the function f of x is x squared. Okay, so first, just remember that transforming means moving around and stretching and sometimes reflecting a function, right? So just remember here I have this point A that's already been recorded. So let's record point B. So point B is -2, -2. Point C is 1, -1. And point D is 3, -1. Okay? So if we transform those points, A prime based on this mapping statement, so this new A, which we call sometimes A primed, is -3, 5. So x stayed the same and y has been moved up by 4. So A is -3 and y is up at 5, which is actually going to be up here off the graph, right? Then let's look at B prime. Well, x is going to stay the same, so -2, and y, we're going to add 4, so -2 plus 4 is 2. So the new point is at -2, 2. So see how this has gone up by 4, this has gone up by 4? For C prime, x is going to stay the same, and then -1 plus 4 is 3. So 1, 3. See how it's gone up by 4? And then D prime, x is going to stay the same, y, we're going to add 4, so -1 plus 4 is 3 again. So 3, 3, gone up by 4. So that's an example of just translating a function up by 4, okay? All right, so let's look at what that means for parabolas. So parabolas have the base function of x squared, okay? And remember our key points centered around the fact that 0 squared is 0, and then we'll go to the left a little bit, and we'll go to the right a little bit. And then to get the y value, we're just going to take the x and square it, right? So -3 squared is 9, -2 squared is 4, -1 squared is 1, 1 squared is 1, 2 squared is 4, 3 squared is 9. And then I'm going to plot these points. So 0, 0, 1, 1, 2, 4, 3, 9. And then same on the left. Okay, and there's my base function that we're going to work with today. Okay? And remember, we're always going to use it in order of stretch, compress, reflect, and then translate. So, if I have a function x squared, describe the changes and write the new function. Okay? So here, I'm multiplying the function by 2. So because I'm multiplying the whole function, it's vertical and it's a stretch by 2. And then my new function, g of x, would be 2 times the old function. So 2x squared, right? This next one, I'm multiplying x by 2, which means it's horizontal. I'm multiplying it by a number bigger than 1, which means it's a compression because it's backwards. So compression by, and it's always 1 over that number. So compression by a half. So that looks like g of x is equal to, now this 2 was outside the function. This half is inside the function. So my new function is going to look like 2x squared, right? Because that 2 is inside the function. And that's what's going to cause a compression by a half, okay? This one here, we're just adding 4 to the whole function. So it's adding to the whole function. So it's vertical. It's adding. So that means it's a translation. It's just going to be a movement. and it's to the whole function plus 4, so it means it's up 4. So my function's going to be x squared, but then I add 4. So that's a parabola moved up by 4. Okay? Here, I'm adding 3 to x. So because it's to x, it's horizontal. It's adding or subtracting, so it's a translation. So just movement. And because it's to the x, it's right, left, and plus 3, opposite of that is left 3. And my new function looks like, instead of just x squared, it's going to be x plus 3 squared. And that's going to give us a movement left 3. All right. So I'm putting a negative outside the whole function. So because it's the whole function, it's vertical. And because it's just turning it negative, it's called a reflection. And so my new function is going to be x squared, but the whole thing's going to be negative. Okay? Here, we're making the x negative. So because it's to the x, it's a horizontal reflection. And in this case, it's going to be negative x squared. When I square a negative x times that negative x actually simplifies to be positive x squared. So a horizontal reflection has no impact on a parabola. And you can see that. Like if I take this and I reflect it horizontally, one arm just reflects onto the other and nothing really happens. Okay? So let's see what happens if we do a whole bunch of transformations. Okay, so we got to go in order. So first I see that there's a negative outside and a negative inside. So I'm going to say that there's a vertical reflection and there's a horizontal reflection. Okay? Then I can see that the function's multiplied by 2. Well, that means there's a vertical stretch by a factor of 2. Then I see that the x value inside the function is multiplied by 3. So that tells me that something horizontal is happening. It's multiplied by 3, which should mean stretch, but everything with x is opposite. So it's a compression by 1/3. Okay. Then I have this x plus 3. So again, it's happening to the x. So it's horizontal. It's a translation because adding, subtracting just moves the graph. So that's translation. And it's plus 3, so it's 3 to the left. Okay. And then the last thing, minus 1 to the whole function, because it's to the whole function, it's vertical, translation, down 1. Okay, so let's write this new function. So negative 2 outside the function, and then the function, so this squaring, that's the function, is happening to negative 3x plus 3 minus 1. Okay, so what's inside the function, that's what's inside the square. What's outside the function is outside the square. Okay, so let's see this one here. So one by one. Reflections, there is no vertical reflection, but there is a horizontal reflection. Multiplying the whole function by a half, so that's vertical. It's by a half, so it's a compression by a half. This 3 is horizontal. Multiplying by 3 would normally mean it's a stretch, but because it's happening to the x's, it's backwards. So it's a compression by 1 over that number. Okay? Minus 2, so that means it's a horizontal translation. 2 to the right, because it's opposite. And then finally, vertical translation up 5. So let's look at this new function. So I'm multiplying it by a half. What's happening to the x is now happening to negative 3x minus 2 squared, and then plus 5 on the outside. That's it. So let's see this applied to a couple of graphs. We'll see what happens. So make a table of values of the parent function. Let's start with that. So 0, 0, 1, 1, 2, 4, 3, 9, and also negative 1, 1, negative 2, 4, and negative 3, 9. Graph the parent function. So 0, 0, 1, 1, 2, 4, 3, 9. Then same on the left side. So there is the parent function. Okay, done, done. Describe the transformations. So, describing the transformations. There's a negative inside, so that means it's a horizontal reflection. I'm multiplying it by a half, which means it's horizontal because it's inside to the x. It's a half, so it's a stretch, it's opposite. So stretch by, and then it's the opposite of a half, so it's by 2. And remember, we can figure this 2 out by thinking of it as 1 over 1/2 on your calculator if you want. Okay? And then the last thing is x minus 1, which means, again, it's horizontal. And it's a translation. 1 right. Okay. So in order to do this, so we've described the function. Now we're going to make a table of values of the image points. Okay? So first we have to do that mapping statement. So one, I can see that everything's horizontal, so the y values are just going to stay y. Okay? Now the x values, there's a horizontal reflection, so x is going to be negative, so opposite. Horizontal stretch by 2, so it's 2x, and then 1 to the right, plus 1. So negative 2x plus 1. Okay? And by the way, the equation of this new graph, so this was x squared. This new graph is going to be g of x is, so this was f of x. This new function is going to be nothing vertical, but the things that are happening to the x is negative 1/2 x minus 1 squared. So that's the new equation. So everything that used to be in the x is now negative 1/2 x minus 1. Okay, so let's see what that looks like. Y values are going to stay exactly the same, 9, 4, 1, 0, 1, 4, 9. X values are going to be negative 2 times and then plus 1. So negative 2 times negative 3, that's 6, plus 1 is 7. Negative 2 times negative 2 is 4, plus 1 is 5. Negative 2 times negative 1 is 2 plus 1 is 3. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, plus 1 is negative 1. Negative 2 times 2 is negative 4, plus 1 is negative 3. Negative 2 times 3 is negative 6, plus 1 is negative 5. Okay, so let's plot these new points and see what happens. So 7, 9 is over here. 1, 2, 3, 4, 5, 6, 7. And then the y value is at 9. Okay, 5, 4 is 1, 2, 3, 4, 5, 4. 3, 1 is 1, 2, 3, 1. Okay, 1, 0. 1, 0. 1, 0 is 1, 0. Negative 1, 1 is negative 1, 1. Negative 3, 4 is negative 3, 4. And then negative 5, 9 is negative 5 up at 9. Okay, so we can see that this parabola has been translated one to the right. Yeah, the vertex moved one to the right. Horizontally stretched by 2. Yes, it looks like it's much wider than the original one. And then horizontally reflected, well, it's just kind of been spun around. So one arm reflected to the other, which visually has no impact. So that's right. Okay? Okay. Let's look at this next one to see what's happening. Okay, so vertically, I see, first of all, negatives. So there's vertical reflection and horizontal reflection. Okay. There is a vertical multiplying by 2, so stretch by 2. There is a horizontal multiplying by 3, so that means compression by 1 over 3. And then there's horizontal translation, movement, 3 left. And there's a vertical translation, so movement, 1 down. Okay? So first, my function g of x is actually going to be negative 2 multiplied to the whole function. And then x becomes this whole thing of negative 3, x plus 3 squared. And then there's a minus 1 outside the function. So that's g of x. And now let's make our mapping statement. Actually, let's plot the original function first. So remember 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. So 1, 1, 2, 4, 3, 9. Okay, and now let's make our mapping statement. So this is going to map to, so x is going to map to something and y is going to map to something. So first let's focus on the vertical things. So vertical reflection means y is going to be negative something. Vertical stretch by 2 means it's going to be 2y. And then vertical translate 1 down, which means I have to take away 1. Okay? Now, horizontal reflection, which means x is going to map to negative x. Horizontal compressed by a third, so it's going to be 1/3 x. And then horizontal translation 3 left. So move 3 to the left. That means it's -3. Okay? All right, so let's plot these and see what they look like. So x is now -1/3 x minus 3, and y is going to be -2y minus 1. So let's calculate them out and see what's up. So this one, x is -1/3 times 3. We can do that on our calculator and we get 1. 1 take away 3 is -2. And the 9, -2 times 9 is -18. Take away 1 is -19. Okay. This one is going to be 2/3 take away 3, which is -2 1/3, so 2.66. Sorry, 2.33. And then -2 times 4 is -8. Take away 1 is -9. -1/3 times -1 is 1/3. 1/3 take away 3 is -2.66. And then -2 times 1 is -2. Take away 1 is -3. 0 take away 3. So for this one, 0 take away 3 is -3. And then 2 times 0 is 0. Take away 1 is -1. For this one, -1/3 take away 3 is -3.33. And then when y is 1, -2 times 1 is -2. Take away 1 is -3. When x is 2, -1/3 times 2 is -2/3. Take away 3 is -3.66. And then when y is 4, -2 times 4 is -8. Take away 1 is -9. And then finally this one, when x is 3, -1/3 times 3 is -1. Take away 3 is -4. And then this one is -19. Okay, so now we're going to plot these points and see what's happening. So -2, -19. So -19 is going to be way off, so I'm actually going to not plot this one. This one here, -2 1/3 and -9. So -2 1/3 is here, -1, 2, 3, 4, 5, 6, 7, 8, 9. So that's that first point. Second point, -2.66 and -1, -2.66, -3. So -2 2/3 is here, and then -3 is here. -3, -1, that's -3, -1. -3 1/3 and -3, so -3 1/3 and -3. And then -3 2/3, -9. So -3 2/3 and -9. And then the -19 again, I can't really plot. And so you see how this gives me a very compressed graph. Okay? So that is a horizontal compression by a third. That's what you see. So this old graph has been reflected down, it's been stretched vertically, it's been compressed horizontally, and it's been moved 3 to the left and 1 down. So that's my new graph. Okay, so that's how we apply transformations to quadratics.